Welcome guys. In this video we are going to look at question 12 from additional mathematics paper 1 for the year 2023 for the internals. So the question reads, in the following diagram, ABC is the same circle with center O, radius 10 centimeters and angle AOC is equal to 1.876 radians. AXD is a sector of a circle with center X and has a radius of 16 centimeters. Now if you look at this question, we have two centers. The first center is center O. This center O is with the sector AOC. Then the other center is center X. So if this is center X, then this distance is the radius for this sector with center X. Now how can we use the given information to answer the questions that follow? So let's look at the first question. So the first question was find the area of the sector AOC. So AOC, how can we find the area of this sector AOC? So I'm going to shade the sector so that you are able to see the sector whose area we are looking for. So this is the area that we are looking for. Now if you look at what we are dealing with, we want to find the area given the angle in the radians. So what is the formula for a sector? Is this one. So you say area is equal to half multiplied by radius squared times the theta. So make sure this angle is is in radians if you are using this formula. Remember, if you are dealing with the area of the sector given the angle in degrees, the formula is this: area is equal to theta divided by 360 pi r squared. So this is the area of a complete circle. Then this tells us that we only need a portion of that area. So that's the concept behind that. So let's now proceed. We'll say area is equal to half multiplied by our radius for this. So the radius is 10 centimeters, so it's 10 centimeters multiplied by another 10 centimeters multiplied by the angle is 1.876. And when you are dealing with this, make sure that your calculator is in radians. So I'm going to say 10 times 10 multiplied by 1.876. I'm getting a 187.6 centimeter times centimeter. We have centimeter squared divided by 2. So if you divide this by 2, our final answer is 93.8 centimeters squared. So that's our area. So we are done with the first question. Let's move on to question B. So under question B, we want angle AXC. So let's look at the AXC. So the middle letter represents the position of the angle. So if I move AXC, this angle is our angle of consideration. So how can we find this angle, right? So to find this angle, first I'm going to look at how we can come up with the angle XOC. Then with that, we are going now to bring in now trigonometry, where we can use the cosine rule or sine rule to find the distance XC. So what do I mean by that? Let's look at the information that we have. So number one, I'm going to first identify the distance AB. So the distance AB is this odd distance from here. So this distance is 20 centimeters. Now where is this 20 centimeters coming from? So remember, the distance from here up to here is 10 centimeters. What of from here up to here is also 10 centimeters, because the radii are always equal to each other. So that's a point. So that's where the 20 centimeters is coming from. So what I want us to do is, I want to find this distance. So this is distance OX. Now remember, from here up to here is 10 centimeters. Then from here up to here is 16. So if I can subtract 10 centimeters from 16, I can be able to find the distance OX. So I'm going to say OX is equal to, so we'll say AX minus AO. So OX is equal to, what is our AX? Is 16 centimeters minus 10 centimeters, which is giving us 6 centimeters. Okay, so let's now get rid of this. So from O to X, the distance is 6 centimeters. What of O to C? So this is a radius, so is this. So we know that radii, 2 radii, or 3 radii, or more radii have the same value. So this one has the distance of 10 centimeters. So if you have these two distances plus the angle, we can find the distance XC. So how can we find the angle, this one, XOC, given in radii? So the formula is, so say XOC is equal to, so you say pi minus this given. So in radians, you subtract the given angle from the pi, because a straight line adds up to 180, but radian, a straight line is equal to pi. So minus 1.876. So on your calculator, you can now, first you punch shift, then there is a symbol for pi where there is EXP minus 1.876. So I'm getting 1.266 as my angle in radian. So this is the angle at this point. So now we can use the trigonometry to find this distance. So now according to trig, this distance is distance O, then this one is small letter x, then this one is small letter c. So the formula is O squared is equal to c squared plus x squared minus 2cx cos O. So let's look at what we have. What is our c? C is 6 centimeters squared, plus our x is 10, so 10 centimeters squared minus 2 times 6 times 100 cos c. What is our angle in radian? Is this 1.266. So O squared is equal to 6 squared is 36 plus 100. So now I'm going to calculate 2 times 6 times 10, then times cos 1.66. Remember to make sure that your calculator is in radians. So I'm getting minus 36.011875. So O squared is equal to 36 plus 100, will just give me 100. I mean, this should be 136. So we have 136 minus 36.01. So if we subtract 36.01111 from 136, I'm getting 99.999. Then we take the square root, also here the square root, or is equal to, what is the square root of 99.999? So I'm getting about 9.9999. So if we are to round this off, we can get the value of 10 centimeters, which simply means that the distance xc is 10 centimeters. Now, how can we use that to come up with the angle here? So if this is 10 centimeters, then we can conclude that the distance OC is equal to the distance XC. Then if this is true, then the triangle OXC is an isosceles triangle, which states that the base angles must equal to each other. So if at angle XOC is equal to, if angle XOC is equal to 1.266, even this must be equal to 1.266, because we want these two base angles to be equal. So therefore, we'll say this is equal to 1.266. Right. Right, we move on to now question C. So question C, we want the area of the shaded region. So how can we come up with this area? Okay, so if you look at this given figure carefully, this party, this is the sector. This is the sector, so we can find the area of this sector. So how can we find this area? We know that we have this angle here. It is 1.266. So let's find this area. So we know that area is equal to half r squared times theta, which is radius for this one. We are using this distance here, which is 16 centimeters. So we have 16 times another 16, then the angle is 1.266. So area is equal to 16 times 16 is giving me 256. Half of 256 is 128. So say 128 times 1.266. So the area for this part is 162.04 centimeters squared. Now we need to find the area of this part, this area, this one, so that if we can find the area of this part, subtract it from the area of the whole sector, we'll be able to find the area of the shaded part. Now remember, this area, we have it already. We found this area at first. This is the area that corresponds to, should be this one. So this is 93.8. So we are going to say area of shaded party is equal to 162.04 centimeters squared minus 93.8 centimeters squared plus C. Plus C, there is another area that we are supposed to have, because 93.3 is for this sector, this one. So we need to find the area of this triangle here. So remember, this angle is given is 1.266. Let me get rid of this so that we don't confuse. And this distance is known. This is distance, we say it is 6 centimeters. Then this is 10 centimeters. So we can use now the sine rule to find that area. So according to sine rule is half AB sine C, which is, we'll say half. A and B are the two distances. So this 6 multiplied by this 10, then multiply by sine 1.266. So what's our area? So 6 times 10 multiplied by sine 1.266, I'm getting 57.2 divided by 2. My final answer is 28.617. So this is now the area for this triangle plus the area for this one. We have it, then subtract it from the area of the sector, then we have our answer. So say plus 28.62 centimeters squared. So 162.04 centimeters squared minus 122.4172. So according to my calculator, I'm getting the value about 39.62 centimeters squared. So that's it for this video. Thanks for watching.